Hello viewers, welcome once again to my channel, Israeli Maths Concepts. In this tutorial, I shall take you on the calculation of variance and standard deviation of a set of data not involving frequency, and that is specifically for ungrouped data. If this is your first time of viewing, please consider subscribing to my YouTube channel and as well hit the notification bell so that whenever I drop a new math content, you would be notified. Before the end of this video, I will solve this given example on the board pertaining to the calculation of variance and at the same time standard deviation of a given set of data. Remember that variance is a statistical measure that is used to study the dispersion of a set of data from the mean, while the standard deviation is just the square root of the variance. So whenever you are asked to calculate the standard deviation of a given set of data, it is very simple to do so. First of all, find your variance, and after which you then find the square root of that very variance you've gotten, and the square root of the variance value you've gotten is automatically your standard deviation. All right, I want to take the example on the board. The example says, find the variance and standard deviation of the set of numbers, and the numbers are 2, 5, 6, 3, and 4. All right, the question requires us to find the variance and standard deviation of this given set of data. And it is very simple to do it. Once we find our variance, we then square root the value of our variance, and then it will give us our standard deviation. But there are two ways to solve this. The first way is to solve it with row method, but for precision and clarity, I shall use the second method, which is the method of solving it using your table. But before I solve, I want to state the formula of finding your variance. And the formula for finding your variance is very simple, and that is your variance V. And your variance V is giving us the summation of, in bracket, x minus your bar x, and that is all squared all over n. This is basically the formula for finding the variance of a given set of data that does not involve frequency. And looking at the formula, we have x. X are just the individual scores we have here. Then the bar x simply means the mean of this given set of data. Then the n in quotes stands for how many data do we have here. Let's count it: 1, 2, 3, 4, 5. That is the meaning of the n. Okay, we want to also state the formula for calculating the standard deviation of a given set of data. And I say that standard deviation is simply the square root of variance. Hence, this is our variance. So our standard deviation is very simple, and that is the square root of this variance. And that is something as saying the square root of what is our variance. Our variance is all this formula, which is summation of x minus bar x, close bracket, raised to the power of 2, that is square, and that is all over n. So what are you learning today? That standard deviation is equal to the square root of variance. And of course, this is the formula for variance, and this is the square root, which indicates the standard deviation. All right, to find the variance of this given set of numbers, I said prior that I will use the table method. It is very simple to use the table method. First thing first, draw the first horizontal line, then cross it with your first vertical line. The first parameter we have, remember we are trying to find the variance. First of all, the first parameter we have based on the variance is x. So I put x here. Then the second parameter combined is x minus bar x. And remember, bar x is the mean. So I will have x minus bar x at the second column. Then for the third column, the next combined parameter we have here is x minus bar x, all raised to the power of 2. So here I will have x minus bar x, all raised to the power of 2. I guess we are through with imputing the necessary parameters and the combined parameters that would enable us to calculate for our variance and at the same time for our standard deviation respectively. All right, coming here, the x are the individual scores we have here. And remember, the individual scores we have here are 2, 5, 6, 3, and 4. That is the x in quotes. But I want to arrange these numbers in ascending order. That is from the smallest to the biggest. And the smallest number here is 2. So we have 2, followed by 3, followed by 4, followed by 5, then followed by 6. So these are the numbers here arranged in ascending order from the smallest to the biggest. You can as well arrange it from the biggest to the smallest. That is descending order. It doesn't matter. It will still tend you to the same answer. Then coming to the second column, remember these are rows, then these are columns. So coming to the second column, we shall be subtracting our mean, which is bar x, from our individual x, which are our score. That tells us that there is need for us to first of all find our mean. Hence, to find our mean, it is very simple to do so. Remember that the mean of a given set of data that does not involve frequency is given as mean, which is bar x, and that is equal to summation of x all over n. What is the meaning of summation of x? Summation of x means to sum all the values of your scores. And let's sum it. We have 2 plus 5 plus 6 plus 3 and plus 4. Okay, and that is all over. And what is our n? Our n means how many data do we have here? We have 1, 2, 3, 4, 5. So that is all over 5. And the mean is equal to 2 plus 5 is 7. And 7 plus 6 will give us 13. And 13 plus 3 will give us 16. And 16 plus 4 will give us 20. So we have 20 all over 5. And remember, 20 divided by 5 will give us 4. Hence, our mean is 4. So back to our table here. The second column says x minus bar x. So we shall be subtracting the mean, which is bar x, which we've gotten to before, from this given set of scores here. So the first score, which is our x, is 2. So I will now say 2 minus this 4. And 2 minus 4 will give us minus 2. Then the second x is 3. And 3 minus our bar x, which is 4, will give us minus 1. The third score is 4. 4 minus 4, which is our mean, is 0. The fourth value or score is 5. And 5 minus our bar s, which is 4. 5 minus 4 will give us 1. And the next score is 6. And 6 minus our 4 will give us 2. All right, we are through with finding the values for this second column. Remember, x minus bar x is just trying to tell you the deviation of this score from this given mean. All right, for the third column, we have the square of x minus bar x. That is the square of our deviation of our score from the mean. Hence, we shall be squaring all the values in this second column. That is the meaning of this third column. So starting with the first value, which is negative 2. So I will say now negative 2 raised to the power of 2. So I have negative 2 raised to the power of 2. And that simply means negative 2 multiplied by negative 2. And that will give us 4. Because minus multiplied by minus is plus. But plus is invisible. Then 2 multiplied by 2 is 4. So I will have just positive 4. Then for the second value, which is negative 1, when we square negative 1, it simply means negative 1 all squared. which is the same thing as -1 multiplied by -1, and that is equal to 1. So here we have 1. Then 0 squared is 0. 1 squared is 1 multiplied by 1, which is still 1. Then 2 squared means 2 multiplied by 2, which is 4. All right, I guess we are through with the third column. Then we want to find our variance. The formula for our variance says summation of, in bracket, x minus by x, all raised to the power of 2. That means we want to sum everything that pertains to x minus by x raised to the power of 2. That is the meaning of the numerator we have here, which is summation of x minus by x, all raised to the power of 2. We want to sum everything in this side. So I will now have that the summation of, in bracket, x minus by x all squared will simply give us 4 plus 1 is 5, 5 plus 0 is still 5, and 5 plus 1 is 6, and 6 plus 4 will give us 10. So here we have 10. All right, all over our n. Remember, what is our n? Our n is how many numbers do we have here? We are coming to that. So to find our variance, I will then say that variance, which is v, is equal to, what is the summation of everything we have here? That is what we sum to be 10. So I have 10 all over. Our n is how many numbers we have here? And that is 1, 2, 3, 4, 5. So I put 5. And obviously, our variance, this implies that our variance is equal to 10 divided by 5 will give us 2. All right, the variance of this given set of data is simply 2. That sounds very simple. Then we are asked also to find the standard deviation of this given set of data. You don't need to redraw your table. This same table serves your same purpose for finding your standard deviation. And since we found our variance, remember that our standard deviation is equal to square root of variance. Hence, our standard deviation is very simple to find, and it is square root of variance. And what is our variance? Our variance is 2, so we take the square root of 2. Automatically, our standard deviation is equal to, when we take the square root of 2, just punch with your calculator square root of 2, and that is equal to, from my calculator, I have 1.4142. So I have 1.4142. Let me just write it here for convenience, 1.4142. All right, this is our standard deviation, but you can approximate it most especially to 2 decimal place or 1 decimal place, since you have it in decimal. So we have, that is equal to 1 point. If I'm converting to 1 decimal place, I will just have 1.4, because the number after 4 is not up to 5, so I run it down. Hence, I have 1.4. So the standard deviation of this given set of data is equal to 1.4. All right, thank you for viewing. Thank you for watching. This is basically how to calculate for the variance of a given set of data and the standard deviation of a given set of data that does not involve frequency. Catch me up in my next class. I will tutor you on how to calculate for the same standard deviation and variance of a given set of data which involves frequency. Remember to share this video if you found it useful. Thank you and see you next time. Goodbye. Thank you for viewing. This is basically how to calculate for the variance and standard deviation of a given set of data that does not involve frequency. And this formula